Hello everyone, this is Professor He. Nice to see you again. The topic of this task is about the isochoric process. It should be pointed out that a quasi-equilibrium process is an idealized process and is not a true representation of an actual process, but many actual processes closely approximated, and they can be modeled as quasi-equilibrium with negligible error. Engineers are interested in quasi-equilibrium processes for two reasons. First, they are easy to analyze. Second, work-producing devices deliver the most work when they operate on quasi-equilibrium process. Therefore, quasi-equilibrium processes serve as standards to which actual processes can be compared. The conversion of thermal energy and mechanical energy is achieved through the state change of the working fluid. That is, the thermal process. The thermodynamic process is not only the state of change, but also the basis of the thermodynamic cycle, which is one of the important contents of engineering thermodynamics. Process diagrams plotted by employing thermodynamic properties as coordinates are very useful in visualizing the process. Some common properties that are used as coordinates are temperature T, pressure P, and volume V. The prefix ISO is often used to designate a process for which a particular property remains constant, such as isothermal process, isobaric process, isochoric process. According to the interaction between the thermal system and the surroundings, a process can also be divided into no-work process, adiabatic process, mixing process, aeration process, and deflation process. Let's talk about the definition of the isochoric process. Isochoric process is a process during which the specific volume V remains constant. For example, a heat addition or heat rejection process can carry out while keeping the specific volume constant, such as the process performed in the Stirling engine and the heating process of the popcorn machine. Secondly, let's talk about the property relations for isochoric process. Recall the first ds equation, equation 530, that has been derived. The relations between the properties for an isochoric process of ideal gas can be derived easily as. Now, let's talk about the PV and TS diagrams. These are the isochoric processes shown in the PV and TS diagrams. An isochoric process of ideal gas can be shown in the PV and TS diagrams, where path 1 to 2 is the heat addition process in the isochoric process. How about path 1 to 2 apostrophe? Pay attention to the slope of the isochoric path line in the TS diagram and try to derive it. Actually, it can be found from the first ds equation for ideal gas directly. Finally, let's talk about the calculations of work and heat in an isochoric process. Without friction, the expansion work, technical work, and heat addition for the 1 kilogram working fluid for isochoric process can be calculated as follows, where the properties such as internal energies or pressures can also be got from the property tables. Okay, that's all for this task. Thank you very much and see you next time.